have a schedule. It's on this kind of gold packet. You should all have a copy of this. I don't know if I've got extras. Um, this week, we have to finish up last week, so we are a day behind. And then I will see you Tuesday, but not Wednesday. And Wednesday night there is a study session on what I've talked about so far, and including today's. Then Thursday night is a study session on related rates. The study sessions are in the forum Wednesday and Thursday. Yes. 6 to 9 p.m. You do not have to come for the whole time. Basically, we're doing the teaching in class and working on the problems at night. You need to be studying. There's only 3 weeks left. You definitely need to do all the multiple choice exams and make sure you understand the questions and bring in questions. I'm here in the mornings, and the mornings it's not dedicated to any particular topic. So if you do some problems, you want some help on them, bring them in the morning. And so the nights we do have topics, and you can certainly ask other questions. But if there's 100 students, it may not happen. There's going to be a lot of students at the AB study sessions. And I'll decide if I'll do the BC or not this week. I may just do AB. Okay. So that's your schedule. Next week, Monday and Tuesday. And the week right before the exam, Monday, Tuesday, Wednesday. And we'll be working in the lab. And that'll give you practice with the 97, 98 multiple choice. And free response. But I would do the 97, 98. I would do them in the lab because they're in the lab when we go into the lab. And it tells you how to do the problem if you don't know how to do it. It's really quite nice. Or you can use the lab to be looking up FRQ answers. But you've got to be doing problems. So at least a half hour a night, you should be okay. The goal is you're not going to get 9 points on a problem. You're going to get 6 out of 9. Huh? It won't. Nobody's ever gotten them. Never. Nobody's ever gotten a perfect score on the AP exam. Are you stealing mine? I'll have to get another one. Okay, so let's do this. This is what we're going to do. We're going to start with the definition of a derivative. And why am I going to worry about this? For one, they could ask you to use the definition of a derivative. You're hoping they don't. But they could give you a limit that ends up being a derivative. And it's nice to recognize it. We do have alternate ways of looking at that. I think it's somewhat in the packet. Okay, I'm going to call this my C value. And we're going to go over a certain distance over here, and we'll call that distance H. This is just reminding you. And all a derivative is slope. It's it. So this is C plus H. Do you remember this straight line here we called the secant line? So we're going to just jump right into average rate of change and instantaneous rate of change because it's kind of asking us to do that. So the average rate of change is just the slope of the secant line. Seriously, it's just slope. They will ask you that on the exam. You will find FRQ questions that ask for the average rate of change. And it's only asking for the slope. There's no calculus. So let's see. What's this ordered pair here? If that's f of x, it's c comma f of c. Then what's this ordered pair over here? C plus h, f of c plus h. What's the slope between those 2 points? There's no slope. It's the change in the y values divided by the change in the x values. I like leaving this as c plus h minus c because now I see slope. When I make it h, I don't see slope. Well, I do now, but not in the beginning when I first started learning this. And that's it. That's the average rate of change. So what is the instantaneous rate of change? So that's the rate of change at an instant. So what I'm going to do is grab this point, and I want the average rate of change. I want to get this point closer and closer and closer. Ideally, I want it to be the same point there, but I can't do that. Because to do slope, I must have 2 points. But what's happening to h? It's getting smaller. So all I'm going to do is take the limit of that. So it's the limit as h goes to 0. And it is f of c plus h minus f of c all over, and let's go ahead and simplify that, h. And that's the definition of a derivative. They could ask you to find the derivative of something using the definition. And how can I prove that the limit of 1 plus x to the 1 over x is e? To prove that, I must use the definition of a derivative to do that, and I need to use the quick way to do it and say that they're equal. That's how you do it. So you might have to know the definition of the derivative. So let's do a quick example. They might give you this. The limit as h goes to 0, and it's the sine of 2 plus h minus the sine of 2 all over h. And I don't want to do that. That's too much work. Do you even know how to expand the sine of 2 plus h? Yes? No? No, I don't remember. I think if I do, it's going to take me time. Remember, 2 minutes on average for your multiple choice questions. So I can recognize this and say, oh, this is f of c plus h minus f of c all over h. What's my function? We'll show you 2 ways to do this. What's the function? It's the sine of x. And where are we finding the derivative? We want to find f prime of what? 2. No, the c is 2. See that? So c is 2. So I can do that. What's f prime of x? What's the derivative of sine? Cosine of x. And so now I want f prime of 2, which is the cosine of 2. That's all they're asking. Now, it didn't take me very long to do it that way. Then in the last class, they said, well, can't we use L'Hopital's rule? Remember L'Hopital from last week? Do I get 0 over 0 if I plug in h equal to 0? Yeah, I do. So what is the derivative of the sine of 2 plus h? Because actually it's quite nice. What's the derivative of the sine of 2 plus h? What's the derivative of sine? Cosine. It's cosine of 2 plus h. What's the derivative of the sine of 2? It's a constant. It's 0. That's just a number over the derivative of h, which is 1. Make them x's if you don't like the h's. Now, substitute in 0, and you get the cosine of 2. So there's 3 ways to find that limit. There's the old-fashioned way, which we expand that, if I know how to do that, or I recognize it as a derivative, or I use L'Hopital's rule. And it doesn't matter, because this is multiple choice. Oh, I'm on the wrong one. Dang it. I wanted the calculator one. So there was one in the calculator section, I believe, in 1979. No, I'm sorry, 1977. See if I can remember this. I think it was 79. Yes, let's look at 79. Pardon? L'Hopital's rule says if I get 0 over 0 when I evaluate it at h approaching 0, then I can use this, and it's the derivative of the sine, which is cosine, times the derivative of the inside. But it's with respect to h. If you want to change all those h's to x and feel more comfortable, that's fine. It doesn't matter. What's the derivative of h? That's 1. Okay, so let's look at this, because this is a hard question. This is 1997. Then I'll do the same in both classes. This is 79. And you don't have to get your packet out. You can just look at the problem. So every topic I talk about will be on the exam. And then it says, which of the following must be true? Okay, so the key word is must be true. What does this statement tell us? That's the problem. What is this telling us? What is this? F of 2 plus h minus f of 2. F of c plus h minus f of c all over h is the derivative. And it says that the derivative at 2 is equal to 5. So is it differentiable? Yeah. Now, do you remember what's true? If a function is differentiable, does it have to be continuous? Yes, it does. So therefore, f must be continuous. That's true. But the next question is, and this one's the hard one, the derivative of the function's continuous. I just know what the derivative is at 2. I don't know about any place else. So I don't know if the function's continuous there. So this is not a must be. This is I don't know. So the answer is the one with 1 and 2, which I think is C. And I think that's a hard one. So you see how they're going to use a derivative to get you? The definition's going to be there. Now, you know, it's 1 point. But how many times can you say, I'm not going to worry about the 1 point before you get no points? So you have to worry about something. So that's one of them. This is one wrong. Okay. And what's the next thing? Oh, we have another form for the definition of a derivative. Do you remember the other form? This is the one I like, but I don't know if you guys like it. Here's my function, and I'm going to draw my line again. But this time, I'm going to call this one C, and I'm going to call this one X. What is the average rate of change labeling my function this way? That ordered pair is C, F of C. This is X, F of X. So what's the average rate of change? Oops. The average rate of change is just the slope. So what is that? What's the slope between these 2 points? F of X minus F of C over X minus C. That's it. So they could give you something like that. Still the same thing. Because what is X minus C? This distance is H. That's H. You see that? That's H. Okay, and if I want the instantaneous one, then I want to take the limit of this thing, F of X minus F of C all over X minus C. And I need to know what I want to take the limit of. I'm going to take this point here, and I'm going to drag that point down the curve, and it's going to get closer to what? X is getting closer to C. So X approaches C. And we've seen that before. There are 3 ways to do a problem like that. We've done this problem a number of times. As limit as X approaches 2 of X squared minus 4 over X minus 2. Some of you just look at it as a limit. Okay, Stephen? This is it. 3 weeks. This is all you get. Okay? You could factor it. Okay, you guys? Declan, we could factor it. We know how to do that. We could use L'Hopital's rule because I get 0 over 0. What's L'Hopital's rule say? I take the derivative of the numerator, which is what? What's the derivative of that? 2x. What's the derivative of the denominator? 1. Put in 2, and 2 times 2 is 4. I could do it that way, or I could recognize this and say that this is f of x minus f of c over x minus c. And L'Hopital's rule is nice, provided it applies. What is my function here?
How do you know if it applies or not?
You have to get 0 over 0 or infinity over infinity. I recognize this as a derivative. What's my function? What's f of x equal to? X squared. What's my c value? C is equal to 2. So I want f prime of 2. So what's f prime of x? 2x, right? So what's f prime of 2? 4. So there's 3 ways to do that problem. You only have to find one. So it doesn't matter to me which one you use. But sometimes they can force this on you, just like they did for this other problem up here. They forced us to use the definition of a derivative. And that's a hard question. You certainly should have 1 and 2 chosen. The question is, do you choose 3? We just don't have enough information to know about the derivative of the function if it's continuous. This just tells me the derivative exists. And let me think a little bit more on that and maybe come back to that tomorrow. Okay. So that's differentiability. And now we're going to do, what do the derivatives tell us? What does f prime tell us? That is the slope of the tangent line. That tells us a whole lot about our function. If our function's doing this, what's true about the slope? Even if my function's concave down, what's true about the slope? It's positive. So if f prime is positive, what's true about the function? Is it increasing or decreasing? Still increasing, even though it's increasing at a slower and slower rate. So f increases. Can you guys remember that? Trying to avoid the memorizing, because there's stuff you do have to memorize. But this isn't too bad. What if f prime is negative? Then f what? Decreases. Is that okay, Zach? Do you remember that? Okay. What does f double prime tell us? F double prime gives us concavity. We'll get to inflection points in a second. If f double prime is positive or greater than 0, I'd rather use that, then that means it's positive, so you're happy. It's concave up. If f double prime is less than 0 or negative, and we're all getting pretty negative about lack of spring, that's down like a frown. That gives you your concavity, concave up or concave down. Now, for an inflection point, f double prime simply must change sign. Inflection points. Has to be a point on the curve where f double prime changes sign. I don't care if it's positive, negative, or negative, positive. It must change sign there. Where are the candidates? Where are you going to look for this? The candidates, and not all candidates win, unfortunately. The candidates are where f double prime is 0. People seem to get that. Or f double prime is undefined. People want to say that's not a candidate. Yes, it is. It's a critical point, just like we do for derivatives. You always have to look where f double prime is 0 or undefined. So I gave an example of y equals 1 over x. There is no inflection point here. Even though second derivative is undefined at the origin, but that's because, what's true about f of 0? It doesn't exist. So the point has to be on the curve. You're right, this is concave up. This is concave down. There is a change in concavity, but there are no inflection points. Because the point has to be on the curve. Picky little detail. How do you know with a first derivative if you might have a maximum or minimum? Here's a max. What's true about the first derivative? First derivative here is positive. First derivative here is negative. Here's a min. First derivative here is negative, then that's positive. So for a max or min, what has to happen with the first derivative? It's got to change sign. For max or min, f prime changes sign. So tomorrow when I see you, make sure you bring your packets because we're going to do problems. Less of this. I just have to get through this. This is all of chapter 3. Remember how long chapter 3 was? It was long. Okay, ready? There are like 5 theorems you must know. This is one of them. This is the max-min existence theorem. And usually, I want to use this theorem when it applies, but not always. There was a recent exam question where was actually harder than doing it a different way. I didn't like that because I really thought this was their intention here. Does anybody know what has to be true to be able to use this theorem? Okay, we're getting ready for the exam. No it's. You got to give me a subject. The function, that's right, must be continuous. That's excellent. Nope. On a, what kind of interval? Closed. The differentiability piece is with the mean value theorem, but we're not doing that today. So you have the max-min existence theorem, mean value, intermediate value, and then 2 fundamental theorem of calculus, and then derivatives of inverse functions. Interval. Call it AB. So if I have that condition, then what must be true? If you have a continuous function on a closed interval, what has to happen? F of x must have both a max and a minimum value. They will never trick you. If they ask for a maximum value, it's going to be a maximum value. If they ask for a minimum, it's going to be a minimum. I've never seen them say, ask for a max and find out there is no max. Not going to happen. Okay? Now, we're not talking about the x values. We're talking about the value of the function. Make sure you answer the question. So we're not going to use the word it, and we're going to answer the question. Okay, Max? Okay, so I have a continuous function on a closed interval. I know I'm going to have both a max and minimum value. Where am I going to look for these? Where might these occur? Where are the candidates? Yeah, that's right. Candidates. You remembering this now? And what I'm going over is what you probably should look at the week of the exam. Okay, do I remember this theorem? So it's endpoints. Where else? And the critical points. Where are the critical points? F prime is 0 or F prime is undefined. Don't forget that one. That's always a critical point, even for the second derivative. And I've looked at the responses on the exam, so I know people forget about the undefined one. Okay, how do I know what the maximum or minimum value is, or both? What do I do with those candidates? Evaluate them. Put them back in the function, not the derivative, but evaluate your candidates. So that's what's going to happen with president whenever we vote. I don't know when we vote. Oh, this week? Oh, wow. Okay, so that's what's going to happen on Friday. You're going to evaluate the candidates. You're going to count the votes. You evaluate the candidates in the function. and f of x. Now make sure you answer the question. We're usually asking for the value of f of x. So whatever's the biggest value, that's the maximum. Whatever's the smallest value, that's the minimum. So we can still do another problem from 79, and that's an optimization problem. And that's number 82. Now, the minimum does not apply. It says if y is equal to 2x minus 8, what is the minimum value of x times y? Good problem. Here, where's the problem? Why does this theorem not apply? Certainly, y is a continuous function. X is a continuous function. Its product is continuous. No close in. Now, they're not going to trick you. When you do this problem, it's going to be the minimum. Okay, so I want the product of x times y. Why don't we call it p? That's equal to x times y. I want that to achieve a minimum value. These are those optimization problems. I've never seen an optimization problem in the free response. Not to say it couldn't happen. I've seen maybe little tiny pieces of them, but not like what you have for homework. Nothing is as horrible as that. So the product is x times y, but what's